let's start our first technical session, which is on agricultural mechanization and automation. Just for the notice of speakers, the lead speaker presenter will get 18 minutes, while all other speakers will only get 8 or 9 minutes. Our rapporteurs will be writing down their notes in paper. They'll not have any time to speak, but they will be submitting the paper to our organizing committee. And at last, our session chair will provide his remark based on all the presentations given. Okay, friends, may I have your attention, please? I'm going to be calling our first lead presenter, or the only lead presenter for this session, which is agricultural mechanization and automation. Ladies and gentlemen, if you do not keep quiet and keep talking, I'll start calling out your names because I know many of you in person, so okay. Now, I would like to invite Dr. Shreemat Shrestha, Principal Scientist, Nepal Agricultural Research Council, to provide his, for his lead presentation of this session.
Yes, the topic that I'm talking about is the sustainable agriculture mechanization for the transformation of Nepalese agriculture, in which within the given time, I'll be talking about the status of agriculture mechanizations, and I'm talking about the SAMS, Sustainable Agriculture Mechanization, and the different stakeholders, and even I'll try to cover even the policy. For the foreign delegates, I just would like to just give the overview of agriculture, because before talking the agriculture mechanization, I just would like to give the overview of agriculture in Nepal. It's, Nepal is with the sandwich between the India and China. It's a rock terrain, and elevation ranges from 60 to top of the wall. And so we got a different agroecological diversity, and with its contribution to about 1/4 of its GDP, whereas 60% people are involved in agriculture, and it's the smallholder dominant. And it's basically our agriculture system used to be our subsistence type of agriculture. And dominance, especially the urbanization, and because of urbanization and especially this migration of the youth from agriculture has left the barren land. And because of that, especially monkey menace and different animal menace, wild animal menace in agriculture is one of the problems. And migration of the youth and shying away of the youth from the agriculture is one of the major issues, and especially that is called the especially feminization of agriculture. This is the issue. And we see the outflux of the youth almost it started from about from 95 to 96, 95, 96, and now it has reached the peak. And because of COVID, there was a little bit dip. Lots of people are going out for this especially labor permit, and they are going outside of the country and for the job, in search of job. And at the second graph, you see, we used to be the rice exporting country, and after 2007 and 8, we started importing. Huge amount of rice annually we are importing. And for the transformation of the agriculture, major issue that we need to deal is the food security, import substitution, commercialization of the high-value niche agriculture products, value addition, agro products and agro industries, employment generation. And major theme of especially the major area that we need to address is the especially attraction of the youth in agriculture. This is one of the major areas to make our agriculture more sustainable. Past effort, different effort was there, and because before 2000, government was very silent with respect to agriculture mechanization. As I've mentioned, due to the outflux of the youth from the rural area and agriculture, there has been a really demand for the mechanization from this farmer side and in the rural area. And because of that, serious voice has raised, and especially government has formulated the agriculture mechanization policy in 2000. 14, and because of that, different agricultural mechanization took its place. And especially in the case of Nepal, agricultural mechanization is not the luxury, it's the basic need for the livelihood of the farmers in Nepal. And I'm just telling about the different history of the different introduction of the several technology from the modern metal plow in 1960 to even the drones for the spraying, and at the moment, ranges of the technology are being introduced in Nepal. And with respect to status of agricultural mechanization, at the moment, we got around more than 150,000 tractors are being registered, and at the moment, especially in the hills also, this mechanization is taking place, especially small agricultural machines like the mini tillers and power tillers increasing. And with respect to this crop establishment, still, even though we are pushing a lot of machine, still people are performing the manual method. And weeding, we try to use the small weeders still. One of the major effort on the, especially women, weeding is one of the most drudgerous activities. And harvesting, especially in the plain area, we have already mechanized, but in the hills, we are still trying to introduce small reapers and different brush cutters. And straw management, we are introducing the balers, tracing, especially one of the mechanized area for the mechanized activities, the tracing very successfully we have done, especially in the Terai, and we are trying to introduce in the plain area. Crop processing also, we have almost mechanized all over Nepal. And from the last 1 decade, there has been quantum increase in the adoption of different machines like the sprayer, pump set, tracers, power tiller, mini tiller, even the tractors. There has been quantum, the two agricultural sciences has given a quantum jump in the agricultural mechanization. But after the mechanization, there are also some side effects. One of the is the, especially, as I mentioned, especially in the hills, our livestock animal power used to be our major power. But now people are started with the different mini tiller, mechanical power. Because of that, there has been almost from last 20 years, 40% decrease in this animal power we have encountered. Because of that, especially soil fertility decline is one of the area. Increased forest litter in the forest, that is also in the hills, and we have encountered more forest fire due to the increase this biomass in the forest from 3,000 events to, at the moment, 6,000 events are taking place. Another is increased use of pump set, especially in the Terai. Last year only, we have encountered 29 deaths, accidents due to this electrocution in the irrigation pumps. And tractor accidents, it has increased, tremendous tractor accidents we have increased. What we found is that every day we used finding 2 accidents, and almost every 3 days, almost 1 death of the operator we also encounter. Especially the forest fire, especially increased use of combined harvester. More than 1,000 combined harvesters are being used, and because of that, especially in the Terai area, this burning of crop residue. This is not only a problem of Nepal, this is a regional problem from the India, Nepal, Pakistan, because it has caused a lot of environmental effect on our forest, crop residue burning. Another is one of the very popular implement that farmers are adopting is the rotavator. Because of the increased use of rotavator, the compaction of the soil, resulting in the more plant formation and the decreased infiltration and root growth and increased runoff that we encountered. And also, because of the increased mechanization, the pesticide use is also being increased. There has been a sharp increase in the pesticide use. How to address those negative side effects and get benefit of this increased use of agricultural mechanization? Previously, we used to talk about the agricultural mechanization to increase the labor productivity, to increase the land productivity, and the cost of production, reduce the drudgery. But we now need to focus on sustainable agricultural mechanization. Is the agricultural mechanization the safe and comfort for the operator, addressing the well-being of the consumer, and the minimum effect to the environment? So we need to rephrase our agricultural mechanization as a sustainable agricultural mechanization. The traditional agricultural mechanization, like more talk in the technical and economical aspect, but the sustainable agriculture mechanization, economical, technical, environmental, and social, the whole dynamics we need to think of for the sustainable agriculture mechanization. And with respect to agriculture mechanization policy, it's formulated in 2014, and there are the 4 more pillars. One of the pillars is about talking about especially the sustainable technologies, that's environmental friendly technology and women friendly technology. So our agriculture mechanization policy is very much favorable for this sustainable agriculture mechanization. And agriculture development strategy has also focused on the agriculture mechanization. But the agriculture mechanization policy was formulated before the formulation of our national constitution. So the federal aspect, the institutional development aspect were not addressed as per the agriculture mechanization policy. So we need to revise the agriculture mechanization policy, and the technical and this directive committee should be very much activated. And most important aspect is about the land use policy. This is because the urbanization and the decreasing agricultural land is one of the major problems for the agriculture mechanization, and also policy support for the local production. We got a different extension program, especially we used to have the separate agriculture engineering directorate before, but it has been merged with this especially market development directorate, now working as a central infrastructure development and mechanization promotion. But it could not especially drive the agriculture, this mechanization, this extension program as before. So, but one thing, good thing that happened is about the especially establishment of Prime Minister Agriculture Modernization Project. At the moment, the National Agriculture Modernization Program, it has especially focused on the especially agriculture mechanization, and it is promoting throughout the country, and done the several introduction of the improved technology in this mechanization technology. And there are also provincial agriculture mechanization programs, as well as the local level agriculture mechanization program. But we need to integrate, because these 3 programs are doing in separate, in different directions. We need to align those, all the different programs together, so that in the same line, in the principle of SAMS. And there are also several NGOs and several CGR centers also promoting the agriculture mechanization. And the private sector, very important the part, because after emergence of this agriculture mechanization policy, private sectors has come up, like the NAMIA and the different agriculture. They are also promoting the different new agriculture technologies, agriculture mechanization technologies in Nepal. And with respect to agriculture mechanization technology, some of the area that we need to address is that it need to more focus on it has more focus on the distribution of agriculture machinery. But the thing that they have to do is that the dissemination of the technology, more focus on the dissemination, not distribution. So not only distribution, the training part, the software part, they have to do, revisit the subsidy policy, because the different agencies are providing different subsidies, lots of problem. And more support in the software rather than the hardware. Assurance of the quality machine, this is one issue. After sales service, custom hiring service, and the financing sector is to be more addressed, especially the banks and all, they should be more involved. And the safety of the operator, as I mentioned, more accidents. And the main thing is about the institutional reform. This is the area we lacked from what we envisaged in the agriculture mechanization policy. Institution, we are not building the institution. Our institutions should be strengthened, because in the opening session also, the whole province, only 1 agriculture engineer, 2 agriculture engineers. How we'll be promoting the agriculture mechanization throughout the province? So institutions should be built. This is one of the area, and especially in the local bodies also, more agriculture engineers should be recruited. And CGR centers, they also do strengthen the national research and extension system. They should not work in isolation. And with respect to research, we got the 3 small units, like the Agriculture Engineering Research Center at Kumaltar, and this Ranighat, and the Testing Center, Nolpur. What we have done so far is that conservation of agriculture technologies, and agriculture technology, different agriculture technologies, some validated. We do some validation, and already we are not really inventing the wheel. Already the developed technology, we just test and promote. And there is some innovations also. We do different innovations that just would like to say. And under that, we got the agriculture mechanization machinery testing center. We have already approved the 2 codes, national code, agriculture mini tillers and power tillers. But especially the testing procedure is yet to be approved from the ministry to take its place. I request our delegates, from the ministry to approve our testing procedure. And we are also promoting the safety part, and also training part also we are doing. And especially the institutional is to be developed. It's the old institution. We need to more institutionalize, and we need to more strengthen as per our need. Manufacturing, one of the poor part of the manufacturing is that we are very poor in the manufacturing. Our blacksmiths are at the verge of extinction because of lack of support. And even our tools factory is privatized and it's not functional, mainly dependent upon the imported products. Because the local private sector could not emerge because of the poor policy, unfavorable policy, almost 15 to 30% custom duty and 13% VAT. But for the finished product, only 1%. So the local innovation could not survive at the moment. So we need, especially subsidiary industry also, we should establish, the government should focus, and human resource financing, labor policy, and a systematic and continuous program for the local production. And especially for the research program, and the way forward is that we need to identify because as I mentioned, Nepal is a diverse country, different geographical, different agroecological. We need to provide the scale-appropriate technology from serrated sickle to the combined harvester. There are the ranges of technology we need to targeting, and especially women and environment-friendly technologies, and safety, and especially now the new emerging area is the use of artificial intelligence and automation, application of drones, and use of robots, and the application of AI in the precision agriculture that we need to promote. And increase access, major thing, our Indra also mentioned about the farmers, increase access of the mechanization technology to the farmers. This is one of the central pivotal area that we need to talk. And major thing that what we need to do is, I just would like to summarize, is the land use policy. We have to, for the commercialization of the agriculture, refine agriculture mechanization policy, make favorable policy for local fabrication of the machine, strengthen local blacksmiths, research and development and research-led technology dissemination, not the businessman-led technology dissemination, research-led technology dissemination. We should focus, safe and quality machine for after testing, recognition of the local innovations, and the promotion of the customer. Because as I mentioned, our farmers are small, so only the custom hiring enterprise can, we can promote the mechanization. Institutional development. This is the institutional development. We need to focus. And I think this is the area we need to hammer it. And main thing is that this is the multi-sectoral and multi-dimensional thing, so the coordinated effort from the federal, provincial, local, with the involvement of research, production, extension, dissemination, all sectors should come together under the principle of sustainable agriculture mechanization system, so that we promote the sustainable agriculture mechanization. Important thing is the human resource, because without the human resource, we cannot promote the agriculture mechanization. So the human resource, and for the prosperous agricultural country, so that we transform the present level of subsistence agriculture to the self-reliant and the commercial agriculture, so that in several areas we can export, several areas we can have an upper hand in the production of our agricultural products, so that we become self-reliant on basic food and also import substitution and some different typical areas which we can export and earn foreign currency and lift the status, socioeconomic status of the Nepalese farmers. For that, we need to focus on sustainable agriculture mechanisms. Thank you, sir.
We also have a brief open discussion session at the end for 20 minutes. So if you have any questions, that's the time to put it, or any comments. Now, next speaker is Professor Chayan Saha from Bangladesh Agriculture University, Bangladesh. And Professor, you have 15 minutes.
Good morning and namaste. Honorable Session Chair, distinguished participants, welcome to my presentation. Actually, I'd like to thank Nepalese Society of Agriculture Engineers for inviting me in this August conference. And also thanks to my friend Ramnath Jha, actually, who insisted me to come, but it's really pleasure to come here and meet all of you and learn about Nepalese agriculture. Actually, what Dr. Shrestha presented is a kind of similar trend we can see in Bangladesh, is what is happening. So just I'm going to give brief overview of Bangladesh agriculture and mechanization and their nexus with water and energy. So you see, Bangladesh is a very small country. It's on like 147,000 square kilometer, but population is quite big, 168 million. And you see the male-female ratio is almost same. Yeah, but we have actually cultivable land 54.4%, and out of that we are producing actually mostly rice. It's a rice-based cropping pattern, and also we are producing other fruits and vegetables. And Bangladesh made actually quite good progress in the production, as for example in the rice production in third, vegetable production we are in the third in the world. Also we are producing huge amount of jackfruit, mangoes, and also in inland water fish producing, we are actually quite in single digit. But the problem, this contribution of this agriculture in GDP is 11.2%. But we have the challenge, as our previous presenter presented, that our land is also decreasing by 0.5% every year because of the industrialization and urbanization. And our also labor force is decreasing. It will be 20% by 2030. So we have the huge challenges. And at the same time, we have issue of the climate change. We are one of the climate vulnerable country, and also we are having this labor shortage, and we have also frequent flood and other natural calamities. So we have challenge to keep up our product as we have now. And also we have actually, our production system is linear. We have actually huge loss along the production system in the input and also in the output. And our post-harvest loss in rice is around 14%. In fruits and vegetables, 20 to 40%. It's quite big number. And we are generating waste 61 million ton per year. So what I think that we need to move for actually appropriate machinery, appropriate technology. Also, we need to integrate 4IR machineries like digital technology into the system, so we can achieve, actually, what we are talking about, the climate smart agriculture. So we can combat the environment, and at the same time, we can keep up our production and increase the production system. And then we can achieve probably the sustainable development goals. Right now, you see that in the left side, we have these traditional practices of agriculture. Right now, we are almost, actually you can say the semi-mechanized. And what we can see the advantage of mechanization, reducing the labor, reducing the actually, what you see, that losses, and at the same time also we can increase the farmer's income. So there are multiple benefits, as a previous speaker said. So mechanization is utmost important for sustainable agriculture. And you can see the trend of mechanization. So the 3.24 kilowatt per hectare energy we are actually, using for producing crop. So that means that we are going towards mechanization, full mechanization. And in this case, you see the division of the mechanization from land preparation to irrigation to transplanting. In some of the cases, we are quite in good position in land preparation, irrigations, and other insect harvesting. But some of the cases, we have still more works to do. And in this presentation, I will focus more on this irrigation. You see that we are 95% mechanized in irrigation. And for this, actually, for running the pump, we are using diesel fuel. We are connected with the grid. At the same time, we are trying to using renewable energy, especially the solar. And if you see the intensity of the, actually the pump distribution in different zones and parts of the Bangladesh, you can see mostly we are using actually 1.2 million diesel pump for irrigating the land. At the same time, we are using actually around 5 lakhs actually a pump which are powered by actually grid electricity, and then we are moving towards the solar energy. But the main things actually is you see for keeping our agriculture in the safe side, we need irrigation, but we are injecting a lot of diesel fuel into the system. So we are actually polluting our actually environment. And you see the distribution here that we are using deep tube oil, shallow tube oil, low lift pump for irrigating land, and diesel contribution, see that if we calculate is 1.63 million ton of CO2 we are generating every year from the diesel system. So we need to think of alternative power. So our government made a kind of policy for propagating actually, replacing the diesel pump with the solar-based pump system. And you can see the trend of our initiative and policy. The infrastructure development company limited is a actually autonomous body institution who are playing pivotal role. And you can see the increasing trend of this, actually the grid pump is increasing, diesel pump somehow decreasing, but in last 3 years actually it is increasing again because we want to bring under cultivation the coastal zones. But at the same time, the solar you can see starting from 2012 is increasing sharply. Since I have some, there is a time limitation, I will go very quickly. So actually, solar is replacing the diesel pump. We want to intensify this more and want to replace the diesel pump, and that will actually help to reduce the cost of the irrigation. At the same time, help to reduce the CO2 and greenhouse gas emission. And you can see the different organization like ITCOL, Bangladesh Agricultural Development Corporation, BMDA, they are playing pivotal role of installing this pump. But you see that we have actually huge gap between the installed power and the targeted one. You can see we're supposed to install 18,000 by 2026, but only 3,424 we could install. There are some issues that we need to solve. As for example, initial installation is expensive, the infrastructure installation. At the same time, there is the issue of, if we compare with the grid connected irrigation with the solar, it depends on the solar availability. So we need to ensure that this pump can run overnight even also after sunset. So there are some issues that we need to solve, and also there is an underutilization of this solar system because irrigation, we are not doing irrigation year round. So we need to think alternative. So So excess energy that we are getting from the solar energy, that can be, okay, thank you. So there is a surplus power you can see in the curve. So in this monsoon, actually, we are not using this solar power because we don't need irrigation. So how to utilize this excess energy to making it system more profitable, so people can get back the money as soon as possible. And so keeping that in mind, we are thinking of digital integration of the system, integrating different electric machinery with the irrigation system on site, so people can get the services. And at the same time, you see that the model that right now we are working on, we would like to integrate the small cold storage with the system which we have developed. Also, we have some electric machinery developed, so we want to pilot this system in the farmer scales, in the farmer's field, and at the same time, we would like to integrate the sensors and IoT system, and at the same time, we are actually trying to develop a digital twin so we can optimize the resources and we can actually utilize the energy as much as possible. At the same time, the system, so system can run actually year-round. So currently right now, I'm collaborating with Birmingham City University and then private sector partner, Bright Green Energy Foundation, Water Sanitation and Urban Population with us, and it's funded by UK Research and Innovation. So we are working on that. So the idea is that whatever solution we get, this conference we are bring together here to share our knowledge, exchange our ideas, and exchange our even technologies. So it's not like that what Bangladesh is developing, Nepal and India cannot do. So what Nepal is developing, we cannot do. So we need to come together, bridge the gaps between the research, between the innovations, and between the exchange. So, so with that words, actually, I would like to thank actually the organizer for this conference, and also the funding agency who are actually funding us, supporting us for this initiative. So I'm really grateful to the organizer for honoring me, inviting me in this session. So thank you all. Namaste, everyone.
Next up, we have a technical presentation by Ramnath Saha, Senior Scientist at NARC. You have 8 minutes. Sorry, all rest of the speakers, you'll only get 8 minutes.
Respected Chairperson, respected dear colleague, and all ladies and gentlemen, Namaskar, I am Ramnath Jha. And first of all, on the behalf of Agriculture and Machinery Testing and Research Center, I like to welcome you all for coming 7 minutes, because 1 minute I have already. If you want wireless, you can. Our topic is Agriculture and Machinery Testing in Nepal, Challenge, Opportunity, and Way Forward. As we know, in Nepal, here agriculture sectors, 2/3 population depends on agriculture, and our youth, they are migrating from the agriculture and even from the rurals. So that's why government has a lot of provided subsidy and anything to promote the agriculture, and then for that purpose, a lot of agricultural machineries nowadays after earthquake in Nepal flooding, and their quality, safety, and appropriate technology diverse is not in proper way. That's why many operational accidents and failures occurred. Even our farmers, different stakeholders, they are not getting proper training and things. And from government sides, to promote mechanization. From 1953, mechanization related institutional development started. But in 2018, government realized that we need quality and safe agricultural machinery to promote our mechanization. And then in 2018, established Agriculture Machinery Testing and Research Center under the NARC. But due to unavailability of test regulation and protocol, still we are in partial operation. But this gap severely hampers our quality and even our economic condition also. Now, just I like to show you purpose, main measures. These are our maintain proper standards, their performance, durability, sustainability. Then also safety is our major things. So purpose for also adherence of safety aspects. Their quality test report, financial assistance, like some banks, they want to finance for the farmer to promote mechanization in agriculture through agricultural machinery. So in another countries, they need quality machineries, test report, and based on that, they are also doing finance things. Provide feedback to our manufacturers, local manufacturers, our researchers to design and fabricate the agricultural machinery. Then government agency for making policies and things. And also recommend farmers-friendly mechanizations. This helps the farmers to choose reliable, suitable agricultural machinery to promote mechanization. Sorry. Now, I like to showing you this relation between researchers, manufacturer, and testing center. Researchers, they are developing design, they develop design and prototypes. Manufacturers, based on that, they are manufacturing. And come to the testings. Then testings, after testing, testing centers provide to manufacturers and also we provide feedback to the researchers. How do you improve that things? So these are the relations, and after that, final our quality agriculture machinery come. Now challenges, our major challenges, what is our major challenge here for the testings in agriculture machinery in Nepal? We don't, already Shreemat sir has explained about that our regulation. We don't have test regulations yet. Then our geographical condition we all know, from Terai to mountain, yes. So for that one, different types of agriculture machinery need, there are different sectors of work need, and based on that, we have need the quality machineries. Then for this, we have limited skilled manpower, limited infrastructure, limited budgets. These are our main challenges to fulfill this. But we have opportunity. What opportunity? As our youth migrated abroad, then farmers, they need for the agricultural purpose mechanization. And for mechanization, they needed agricultural machinery. So to promote this one, agriculture mechanization promotion policy 2014 approved by the government. And during that period, me and Dr. Indra sir has several times we have in the meeting, common meeting. And to fulfill this one, in 2018, AMTRC got the birth take place. And then other opportunity we have, farmers day by day they are shifting from traditional to mechanized systems. To promote mechanization, government is also providing the subsidy for them, for the machinery purpose, agricultural machinery. And also nowadays in Nepal, some manufacturing work is started. So to support local manufacturers, to provide feedback, proper input to them, how you improved this one and make the best ones. Then for agriculture innovations, those are our researchers. They are designing and development these things for that one, and to also support policy support and commercialization, like another country, like in our neighbors country in India, government decided their subsidy and things based on the test report of their available machineries. Now, way forward, we are assist the government to promote, develop standard regulation and different protocols, support government agriculture related policy, then also build linkage between different national and international testing related institutions, promote cost effective and farm mechanization tools and equipments in rural and remote, and also farmers friendly, women friendly, youth friendly things. Some just achievements I like to show you. We need for the testing purpose, testing standard. And first time in the Nepalese history, we have last year prepared two standards, for one for power tiller and another for the mini tillers. And that power tiller and mini tillers, what parameters need for the testing purpose, that thing I have shows you around 15 parameters. And another thing I like to show all of you, our AMTRC's testing process, how we are starting the journey. First, application receipts, then random selection, pre-delivery, post-delivery, specification checking, then lab test, lab, indoor lab, outdoor lab, then field test, then their basic safety things, then report preparation, and after report preparation, then submission and approval, these things. A specification checking like this, then engine performance test, driver performance test, turning ability, vibration test, parking brake, noise level, while pullover test. These all are facilities available in our testing centers, and these things. All photographs are testing centers. Nepalese testing center, field performance test, then their dismantling and wear assessment, and now aerial views of our AMTRC in Sarlahi Navalpur. Previously, whole area was horticulture, then in 2013-14, wild research program, and 2074, in the middle, AMTRC. Then memorable moments of AMTRC. We have started our journey from that point, and by this way, one thing I like to show you all. Testing centers first asset is this register and only dot pen. And from that we have started 7 years before. But last year we have successfully organized international levels NTAM, SNN Pacific Network Testing Agriculture Machinery related 1 week's training program. And that training program, 18 countries, and even, including Nepal, 47 participants, agriculture engineers, take participation in that training program. Our land development, when we got the land, place was there like that, and then within a 6 months, we have take place. So one mother need to produce the child 9 months, but if government decide proper and provide proper management and inputs, then within 6 months, we agriculture risk can change the country's scenario. This is our facilities available there. Thank you very much.
Thank you, Ramnath. Now, for the third technical presentation, we have Engineer Samir Shakya from IOE Dharan.
Sorry for the max because I'm going on the treatment of my tooth. Thank you very much, the organizer, for giving me the platform to speak in this huge forum, first of the kind in Nepal, international conference. First of all, to the dignitaries, my senior agricultural engineers, my colleagues, my junior engineers, my student-turned engineers, and the future engineers. On the behalf of Department of Agricultural Engineering, Toronto campus, I would like to give a small information about, we have added 3 subjects. We were undergoing with all the topics right down there. So we added 3 subjects from the last 3 years. We have added sustainable development, we have added precision agriculture, and we have added agri-entrepreneurship in our course. And the fourth one in regards to MSc in land and water engineering, we have added water, energy, food nexus. Thank you very much. I would like to thank for the entire agricultural and engineering fraternity to motivate me to complete my master's, third master's in economics. And this is the slide I'm presenting is all about my master's thesis in economics. And the topic was the economic analysis of custom hiring center in Eastern Nepal. So I recently completed last month with these topics, and my objective was to see 2 hypotheses. How does the rental price affect the custom hiring center sustainability? And the second one was how the rental charge is affected by the operating cost. So I came with beautiful results. I think it will be impactful for the entire policymakers to focus on the upgradement of custom hiring center. So I would like to go with my slides. So it was the margin reality. It's all about the economics and finance. How much profit a farmers gain from a custom hiring center? It was from the range of 9 to 15%. The second one was the heavy advantages of total profit. It came to be 36% by Sagun Krishi Sahakari. And the rational pricing that we saw was the regression analysis that gave a result of R square of 0.97. That was excellent. And to give a background of the study, Nepal is facing a big crisis. Nepalese agricultural economy is driving towards the migration economy. So it's a big problem. It's a big question mark for us. So how should we go ahead? So it's a labor migration. During the phase of agricultural activity, there is no labor, there is a crisis, there is a gap of mechanization. It's rising up, but it's not getting to the point where it should be. And the last solution will be the custom hiring center, where the farmer cannot afford the machineries, they can use the custom hiring center as a service. So there are 14 districts in Eastern Nepal. So I took the 3 Terai districts, Sunsari, Morang, and Jhapa. 3 is custom hiring center from the area of study. So the slides basically shows the cost of the machinery. It's the cost that make impact in the sustainability of agricultural mechanization, the operation cost of the sustainability of custom hiring center. So you can see the combined harvest with a big amount, 48 lakhs price, and we can see a cultivator with 45,000 per pieces. So I think this purchasing price definitely affect the rental charge that symbolically impact on the sustainability of agricultural mechanization. And it's a rental price. You can see the harvest equipment commands of 500% premium over tillage machinery. So you can see hourly rental rate ranging from 6,310 to 1,000 for power tiller. And it's operational dynamics that I find in my study. It's all about the profit. You can see a net profit of 2.05 lakhs by combined harvester in Sagun Krishi Sahakari. In NMC, the track type CS, combined harvest, makes a profit of 1.16 lakh per year. And the mini tiller in NMC hits a net profit of 0.12 lakhs in NMC. So it's a profitability game. It's a game of benefit cost ratio. It's a game of economic rate of return. So we can see Jivan Vikas Samas has the highest leading position of 15.37 profit margin. That shows that, and the lowest is something around 9.07. Is the point that I was seeking for was how? The answer was the Jivan Vikas Samas make a big profit due to the multiple use of machineries. And it's a case study of power of scale. You can see Jivan Vikas Samaj with 39.40 profit margin, 31.53 profit margin by track harvester, and the challenge that we treated was the revenue, 76 lakhs by JBs, and the lowest 16.4 lakhs by the Rupandran. And it's a profit pool, combined harvester giving a profit of 36% to a list of power tiller gives a profit margin of 2% only. It was the regression analysis R square. So we just made an average of 14% profit margin as a whole. And the strategic vulnerability was the thin margin. It's all about the competition that goes between the cluster buying centers. So due to the competition, the hiring center reduced the price, so the impact will be unsustainable for the community. And it was the asset specialty is very expensive, combined harvester, so government is giving subsidies, that's okay, but the concern is about reducing the taxes much more than that point of level. And the pricing pressure was something like, just like the government of Nepal gives a price of labor in each district. So I humbly request to the policymakers to make a Jilla Dar rate, district rate for each component of machinery. I think that will be beneficial for the sustainability of agriculture and engineering. And the strategic roadmap of the policymaker, subsidy from basic tillers to high impact machine harvester because the harvesting machine gives much more profit. Establish maintenance grant for to protect asset life. Means it's all about maintenance. It's about operational. It's adopting a digital booking system. Mobile is not for Facebook and TikTok. Mobile can be used as a data logging machine. So regarding financial, we just need a diversification in agriculture. So that shows the strict cost plus pricing discipline that helps to be much more sustainable to the entire agriculture community in Nepal. And my conclusion was to scale up, what's going on, to mix the assets, multiple machineries, and the rational pricing to make a discipline to sustain. And basically, as regard to United Nations Sustainable Development Goal, this study hits the target 1 and 2, no poverty and zero hunger. Thank you very much.
Thank you, Samirtai. Now next up we have Engineer Subash Adhikari, Secretary of NSAE, with his technical presentation.
Thank you very much. And I'd like to thank everyone for your different kind of roles and your presence here, which has made this conference valuable, and we are able to organize this event and to present our work. So today here I am going to present to you about a work I have done in my previous organization. So when we were at the end of one of the project, CISA, Serial System Initiative for South Asia. So one of the things we thought that we worked in agriculture technology, and one of the major agriculture technology we were working there was the agriculture mechanization. So the agriculture mechanization data we have from 2009 to 2024. There were many valuable data which we think might be usable to the public and the people. So how can we hand over that data to any usable organizations or public? So that was the overall start point, how this work started. And finally, we were able to build a platform, which I am saying a digital platform for sustaining and scaling agriculture mechanization information. And this work, which we have already completed now, because of this conference, it has helped us to make this work into a paper in which we got help from Sanjeev Vimali and Sagar Kafle. So from project data to national infrastructure. Is our Shreemat sir, I want to remind his one of the things that he suggested in policy is different organizations, they are working and we need to integrate their work. So we can see different programs and projects working in Nepal who are providing different kind of support related to agricultural machinery and subsidy program. And how or what happened when they end their program. Actually, their valuable data goes to their either on database or remain as a static. So in this context, is each project they do have their own database, and that database may be unavailable for the users to use. So in that case, how we can make that into a one platform? Can we start from our project CISA, which has ended using that data, to a one national platform where in future any project after the end can give that data and build a mechanization database in the future? So this was our research questions to fill the problem. Our conceptual framework is very simple. Project, it works for a long time of period and generate a very valuable data, but after at the end of project there is a risk of becoming that data static. So we designed a standard structure which can be embedded with a verification and data governance, especially through the governance sector, and that data could be reusable in the future. So in this way, we can able to build a national digital informations, so which can provide a public informations. They can see the map, like our Samir sir, he recently talked about the custom hiring center. So anyone, if they want to know the custom hiring center of Nepal, simply clicking at the right side custom hiring center, they will see all the custom hiring center located in the Nepal. So this can be built in future. And the main thing, the main characteristics of this framework is the data is not, the platform is not completed. In future, it can be reused again and again, the data can be uploaded, so the sustainability loop is included there. So in the operational mode, we started with a simple data collection platform where any individual can collect the data, or either for the project, it could be an Excel file where it can be a bulk file imported in the system. So that file data will be verified by Institute Center for Agriculture Infrastructure Development and Mechanization Promotion Center from Nepal government. And after the data is verified, it will be public in the public interface where we can see the map and download the CSV. So this is how we operationalize and develop the platform. Till now, we don't have much data. Out of around 3,500 data of the project, we were able to get the consent from only 800 around stakeholders. So after taking that consent, we saw that data on the map. So we have only 868 verified records, and we can have the list of 12 categories which can be included in the data. So anyone can visit this QR or the site mechanization.cid mp.gov.np right now and see our work. So finally, the conclusion is, yes, from the project data, we can build a living database. And the learning is like, for the data sustainability, we have to start. Archiving may not be a solutions, and a proper governance and institutionalization is necessary for making it sustainable. Here we have just started. Still a lot of things to be worked on, especially for its successful implementations and how to make it usable beyond a registry. Not limiting it to the registry of machinery, how we can make it usable. Maybe one of the work we can do the mechanization mapping using the same data, which will help us to understand the possibility of different area where which kind of machinery can be promoted and planned. So policy implications, which here the machinery registry integrated with a subsidy program, and the different programs can be integrated here. So especially the use will be the main case. With this, my presentations, I would like to conclude, and thank you everyone for your patience.
Thank you, Subash. He was under 1 minute. So. Now, our final technical presentation is going to be by Dr. Anil Pokhrel, Senior Scientist at NARC.
Now it's time for open discussion.
Open discussion. No more presentation?
No, Dr. Anil is
Okay, thank you very much. So friends, we had really very, very, useful presentation. I really enjoyed, first from Shrestha ji, then Saha ji, Ramnath Jha, then we had presentation from Subash Adhikari, and then one great presentation on cost of hiring. So now floor is open for any query or question. You can directly address to the speaker, and they will try to answer your question. Discussion is necessary. Please do ask some question so that they can, replan even their studies also. Something more you can offer to, to their research and their study program. Thank you. Dr. Syed Ismail, please. You want this one? Thank you very much.
This is regarding the side effects of mechanization. The talk was there. I have some different of opinion because I have worked for the roadmap for the NAS for the present DG of IGRISAT. Okay, we wrote a book. The book we compiled with 15 of the experts in India about mechanization, farm mechanization, under Professor Gajan Singh. So I was the one who was coordinating the whole thing. First of all, the farm mechanization, as we see throughout Asia, is around 50% tractors are used only for transport. This we all know. And tillage has really no sense to productivity. Okay? Once in a while we require to till it a bit deeper because of nematode or whatever may be. That is once in 5 years. We don't require plowing and tillage at all. There is no scientific paper shows that tillage increases the productivity. But we show farm power and productivity. That I agree. We come back to the farm power. But tillage, today is the concept of no tillage or minimal tillage. With that, throughout the world is going on, but we have less, around 20% only covered. I think this is the, first of all, let us forget about moldboard plow, disc harrow, teaching that. And especially rotavator has damaged 40% of the hard pan already. In Bengal and all the area, 40% of hard pan is gone. So wetland is gone. Now, mechanization has happened already. Like I also saw excellent figures were there, around 80%. Only in the cereals, rice and wheat, almost completely mechanized. But we thought agricultural engineering mechanization is tractor. This is wrong. One of the major costs, 30%, I will take 1 minute more to tell and finish. 30% of the cost involved in weeding. Today also I saw weedings. We have not put our mind into weeding. Okay, weeding is 3 methods. One is to pull out the weed, one is to push the weed, third is to burn the weed. The laser things are coming out. How many people have really worked on the weeder? We have not worked. Spraying is another cost. Only 8% of the chemicals reach the target. Rest of the chemical goes in the air and soil. How many engineers work on the spraying system? I have not seen a single one working on how to make it. I remember 30 years back, one of my students worked on electrostatic spraying. Okay, then the Israeli company brought the electrostatic spraying. But I think nobody is concentrating on where the real issues of the farmers.
Thank you.
So mechanization,
Thank you.
we have to rethink.
Thank you very much. Please, these are the points to be noted by the researchers. I will request that if in your presentations you will be suggesting more things. Here if you have specific query and so that they can have better direction of research, that will be nice. How much time is there, madam, for this open session? 20 minutes, please.
Yeah, thank you.
You can address to the speaker. That will be nice.
Yeah,
You
thank
have
you.
question 2 and then you speak.
So I don't have a specific question, but could be a remarks from my side. First of all, I would like to thank all the presenter. Very nice presentation. I could see a lot of things happening already. How our agriculture has started and now where we are already. To be very specific, maybe it's related to Dr. Shrestha. It's a remark that we are also thinking of reviewing agri-mechanization policy. Recently, I have also participated in one program where they were using AI and machine learning for the rural water supply, where they were looking at how the functionalization of the infrastructures actually. So I was also thinking for the sustainability of the agri-mechanization, it's not about looking at how it's working, but monitoring is an important part. So they have developed a tool where they could see from far, like how these, let's say, pump and other tools are working from very far. Like from here, you can see or observe the how the proper location, proper pump in the Sarlai is working, functioning by taking pictures and taking some data. So I think maybe we could open the door if we are actually revising the policy, the door to AI and machine learning for specifically for monitoring. And that's the only thing I want to share. Thank you.
Thank you, thank you. Dr. Shrestha, Dr. Bhim Shrestha.
Thank you, Professor Indra, for giving me an opportunity. I'm Bhim Shrestha. Currently, I'm leading as a director for Nepal Technology Innovation Center at Kathmandu University. And my questions to Dr. Shreemat. One of the slides I noticed there that after having privatized, agriculture's tools factory has collapsed. That was one of the statements I saw in your slides. So what exactly that means? And recently there we see a lot of improvements in agriculture tools factories are going on. And what you suggest, what could be some of our innovative approach to revive those agriculture tools factory? And nevertheless, I don't see any agriculture engineers are currently involved in reviving that agriculture tools factory also. So how do you see the future of agriculture engineers to revive and bring about some innovative approaches to readdress the problem that is being faced by agriculture tools factory in Bitterguns? Thank you.
Thank you for the different queries and different remarks.
Yeah.
With respect to Professor, okay. Yes, please.
He wanted to, please, you want to reply?
Any,
Yeah. It will be better that brief reply.
yeah, okay.
Very brief reply, because otherwise it will get mixed.
Yeah, okay.
Please let him reply and then your question, please.
Okay, with respect to especially the tillage part, I do agree tractorization is not mechanization. That's why we'd like to introduce the sustainable agriculture mechanization. That's why in that part, especially our new agriculture mechanization policy is also going in that direction. The second part, with respect to new agriculture mechanization policy, there are some gaps. One gap I've already mentioned about the different role and responsibility, because our mechanization, previous agriculture mechanization policy was promulgated before the promulgation of the new constitution, in which we got the three-tier government, and our new agriculture mechanization policy should address what role should different tier of government should play. Another part, also especially the recent advances on the machine learning, AI, automation, drones, these new technologies have come up after this mechanization policy. So we also need to capture those new technologies, especially in the agriculture, in that part. And with respect to Professor Beam's regarding the privatization, my statement is not complete. Privatization has not, especially the government has taken the privatization policy, but that policy has not properly executed. Especially the private sector which it selected, they should have some criteria so that who should run the industry. Definitely, the industry should be run by the private sector, but the entrepreneur private sector, not the land, real estate dealers. Especially the real estate dealers have owned that private sector, and in view of using those land area, main aim was that not the agriculture tools production, because that tool production has given a remarkable production in agriculture tools in the previous. Because even we used to have the collaboration with the Kirloskar and producing this agricultural tools factory Kirloskar pumps. So at the time it was giving a lots of produce, and the quality of the agricultural machinery produced by the ETF was remarkable, and it was very much highly regarded the quality of by the farmers. But after the collapse, it could not retain. Major problem with the agricultural tools factory is that any factory should be run by the private sector. That because it is an enterprise. At the moment, the NGO, this National Innovation Center is operating. This is not in a good direction. It should, because the entrepreneur and the innovator should run the factory. For that, our policy is not favorable. Because at the moment, while importing the raw materials, we are putting the custom duty 30% and the 13% VAT. So it's almost 46%. And while importing the finished product, only 1%. So because of this poor policy, especially the private sector could not invest in the production of agricultural machinery in Nepal. This is the bottleneck. We have to open this bottleneck. Only then the entrepreneurs will come up and the innovators will come up, and we can produce the agricultural machinery needed by our country.
Any question from your side?
Maybe my inquisition to Mr. Shrestha, yes, sir, please.
Yes, sir.
I think you focus very much on production mechanization in the agriculture, but we are limiting our opportunity in agriculture production, but not beyond that. Beyond that means post-harvest, agro-industry, food industry, those things. And we are really, those are the areas where there are a lot of employment opportunities with high salary, high facilities, many things are there. But our engineers, our NSAE, Saha, focusing on just production, production, and production. That's one part. Second part is, when you talk about the customer hiring, those things, and I saw the economic analysis, that part is the crucial part, what I see there. When we harvest, harvesting time is for all the farmers at the same time. So there cannot be machines available for all the farmers, especially for the small farmers, not at all available. So that affects pricing very much. That's first thing. And second thing is, when something goes wrong with the machine, a small thing, maybe costing 100 rupees, 200 rupees, and we are very poor in servicing, repairing, and maintenance. And something goes wrong, and your harvester doesn't work. Combine harvester doesn't work. And when the skilled person comes, he just fixing things very easily with maybe just small parts of 100 rupees. And that part is how to operate, how to maintain, how to service. That part is very much lacking, right? And lastly, I want to focus one thing, that I don't know, I may be very wrong, but agriculture engineers, we have to work with agriculturists where we can compete with them. We have to work with civil engineers where we can compete with civil engineers. And we have to work with mechanical engineers where you can compete with mechanical engineers. And where is that? In Nepali, we say, na asko chal, na kukra chal. Right. So we are getting lost on the way. I want Institute of Engineering, they have to think very seriously how to make engineers very competitive. What you can see in ATFF, there is no even a single agriculture engineer who is employed there. They are doing miracles. They are coming out so many machines, different types, in all the fields. Do you think that there is one single agriculture engineer? I don't think so. 2 minutes. So these are some of the initiatives.
Thank you, sir. Especially with respect to the this mechanization, our effort is limited to the production system. And there are also some efforts with respect to post-production, post-harvest. The major limiting factor is the scale of production. Our production system is very much distributed. Unless and until it is systematically located, that's why especially our new project, this Prime Minister Modernization Project, now they are going to develop some zoning of the production system, so that the collection and the distribution, because our production system should be definitely linked with the industries. That is lacking. That's why our production system, we need to develop the different zones, and some new emerging industries are coming, like potato industries. Now they are doing especially all the different post-harvest operation is taking place. Now they are collecting the local produced potato. Similarly, like the feed industry, our this especially milling industries, rice industries, those are not linked with the industries. Especially now at the moment, we are talking with the different industry association, so that how we link our produce with those industries. This is one area. And some area, for example, some simple technology, like niche product, like coffee. We have developed the coffee simple processing, coffee pulping machine that has introduced our coffee to the international market. So you are right that the especially processing part is very important. Another thing that you are talking about, especially with our graduates, because it's rightly they have introduced an entrepreneurship program, and also especially on-the-job training, because at the moment some of the students, because they were raw graduates, so they should work with the industry, some industries, so that the more innovations comes. In that way.
Thank you very much. Thank you. Shuklaji, what is your question? Time is up.
Excuse me. Yes. I am Indra Kalu. My question is not question, is actually suggestion. What I see, we have worked for 50 years in irrigation, and we see land is uneven, our land. And there is, I think you should include the land, laser land labor or something like that.
Very
Because
good.
without that, you cannot go for production, high production.
Very good, very good.
Irrigation
Thank you.
efficiency is so low. This is my just suggestion.
Thank you very much. Thank you. Shuklaji?
Yes, I'm going to be very brief. See, I'm probably the happiest man in the room here because the wheel that we invented back in 1999 to 2000 is now rolling. And it should accelerate in the days to come. I'm sorry, Shreemat ji, all the questions are, directed to you. They are bombarding you. And my simple question is, you are leading, farm machinery, agricultural engineering research center, okay, located in Nepal Agricultural Research Council. My very, pertinent query is, how do you set your research agenda on agricultural mechanization? Because, Dr. Saeed has opened a very pertinent debate. These days, I'm working in a design team. It's a, and then we are designing probably the largest surface irrigation system in the country, Bagmati irrigation project. And I did a field investigation. I dug 300 pits, okay, to explore the soil characteristic in the area. And at each of those sites, I measured infiltration rate. And then one of the observation is that there is, right after 30 centimeter top layer, there is a formation of plow pan. And, that area is undergoing tractor-laid, rotavator-driven tillage operation, both for dry land and also for wetland tillage. So, it's very important that and see, bulk of mechanization is in the country is tillage-led mechanization. Okay, so that's a very pertinent thing, and then we need to seriously look into it. And I would like to end, that, a very important caution is to look into, whether mechanization is going in a right direction. What I see is, it's a subsidy-driven process, and it is resulting into dumping of agricultural machines in our villages, okay? And that is giving a very wrong message of agricultural mechanization in the country.
Now, I would like to intervene, please, because we are running very out of time. We are already, so we also have networking opportunity when we are grabbing our food, water, so we also have to give Professor some time. He was allocated 20 minutes. Now he's just come down to 10 minutes, like all of us.
I'll just, in one sentence, I'll just address some of the issue.
No, thank
especially
you very
with
much,
the. Okay.
Thank you very much. Please, during lunch time, you and tea time, please do interact. This has created a lot of, energy, at least. And I'm really very, very, very happy because we don't see the conferences, creating discussion. And congratulations to you, because if people are saying bombarded, I'm saying respected. You are being respected because the question, if question is being asked, that means people listen to you, people respect you. And this is same for everyone. And on this presentation, I'll take 2 minutes just to convey that, yes, I have been associated with the Nepal agricultural mechanization from last, almost 10 years I'm interacting. Last time also I came, it was on custom hiring. And then also I said that no country can create a sustainable mechanization suitable to terrain, to crop, to system without our own manufacturing. We cannot depend upon, other countries and manufacturers, because they have designed their machine according to their terrain. I'm mentioning terrain because I'm in Nepal. So that terrain, and very, very nicely it was mentioned that at different location, valley is there, mid hill is there, top hill is there, that becomes very, very important. So please, one recommendation that all should be done to basically increase the opportunity of our own manufacturing. This is most important thing. Second one is testing. Why testing is more important? Let me tell you, last time when I came here and making a presentation, then there was a Bangladeshi counterpart, and he said, why do you test this much? A system will take care of, market will take care of. He told me, Saha Saab, उस समय आए थे, he told me that, then now, but see, that testing, why testing is required? Somebody is bringing machine, he is giving, okay, it is suitable, maybe far valley, and you are taking to mid hills, to top hills, then accident because the CG, etc. is to be designed properly. Center of gravity has to be designed of that machine, and don't take tractor as a tractor. I was working for a government program, TREM 5 in India, and I said that government must not say tractor. You call it tractor machinery system. The moment you start tractor machinery system, it is not simply pollution making, it is not simple, that's what tractorization, tractor machinery system should be there. So these two things are means testing, that procedure and protocol and all should be expedited by the government, and manufacturing should be started, and sustainable agriculture mechanization should be done. I have a slide. I was thinking that I have not to present, but quickly I will just go through that what we are happening. You know that India is producing 10 lakh tractors every year. 10 lakh tractors every year. And we are exporting more than 2 lakh tractors, and we have tractor manufacturing center outside the country, including in USA. So mechanization has picked up in India, and Dr. Said made, that report he was mentioning. But even then, I don't say that technologies of India just should be adopted here. They should be customized properly, redesigned. If someone want to come, and establish machinery, he should make machinery as per our need. And there was one that agricultural engineers, the must be number should be increased. You take a lesson from Bihar. Bihar agriculture was very in poor state. There is more and more, agricultural engineers have been recruited. They have been given responsibility. As I said, future agriculture is engineering agriculture, so it becomes very, very important that departments should have more and more agricultural engineers, because that is very much necessary. Here, actually, this, I will not, because, Madam, time? 10 minutes? Huh? Oh, please, just, I will not take this one, you just see that what we call, this has been mentioned, that water, energy, food is a big one, big nexus is there. India realizes, world agriculture realizes, so we have to work accordingly. This is the system that projected impact of climate change. Half of the world is expected that there will be, this green one, and the other one, it is basically where productivity may increase. But the red one, all that climate change is going to affect very, very adversely. And this is the situation in India also. We are 51% is still dryland agriculture. So there we are thinking that what should be the, so we are, ICR has decided, all state universities have decided, no project, no technology which is not addressing climate change. So this is one that is clear-cut message. And we all know that what are key challenges. for the agriculture. So what we have to do, if we have to be food production, we have to go for adaptation and mitigation technologies, just to address climate change. And then here we all know that climate resilient agriculture is the need of the day, and mitigation is one aspect, adoption is another aspect, resilience has to be there, and to finally address food security. I will share this slide with the organizers, and I will request that it can be shared, the thoughts which, with my friends here. Then development, climate resilient agriculture, varieties. This is one thing what we are doing. Low water requirement, varieties, short duration varieties. One challenge, anybody will ask, I have developed a variety, government asks, tell me the duration. If short duration accepted, if long duration rejected. So this is one, how to address the climate, mechanical friendly. There should be addressed that whatever technology, we at Parbhani have developed seed-to-seed mechanization for pigeon pea, for safflower, for soybean, for all these crops. Seed-to-seed mechanization. Without mechanization, we cannot address climate change, because climate change is basically timeliness. If you can address timeliness, you are partially addressing climate change. So that becomes very, very important. These are the some, you will not realize that this is a pigeon pea variety giving 20 kunta per acre. So India is facing, is still importing pulses and oil seeds. So our emphasis is that go for this one. So, and this is a gram variety which is giving ground to podding clearance 33 centimeters, so that you can use combine harvester. So the breeders should be asked to develop varieties which are mechanization suitable. It's not only engineers should develop a tool for their crop suitability. That is one great message should be sent to system. And then similarly, climate resilient variety for oil seed crops, number of oil seed crops. Why I'm presenting that, they can be tested here, those seed and other things if possible, to popularize this variety. We are working on, again, climate resilient agriculture for cotton and millets. Then this is, we call it Trisul technology. So whatever water you are harvesting, then use solar energy, solar pumping system, and then go for micro irrigation system. So with less harvested water, we have to address this, irrigation. My Saha presented that, that becomes very, very important. Morning I was reading one news, and that Philippines is going to, you might have seen, Philippines is going to face what they are calling it from stress, water stress. From water stress, they are moving for water bankruptcy. So now the term has been given, water bankruptcy. Everyone must think about water. I said no. So this is every technology. Climate resilience means you have to, and mechanization and irrigation also has a very good nexus, and that's what the presentation of Saha said. That's a very, very important thing you mentioned. And so what these are the technologies which are, it was mentioned that bullocks, still bullock power can work with tractor power also. This is, and we are ready to give design technologies which are very suitable for animal power. So this is not, let us not say that tractor power will totally replace. Like beading was mentioned, the interculture was mentioned, in Western UP is still, despite all mechanization, bullock power is used for interculture, because they feel that this animal's food make a good suitable land, so those things can be think of. It's not means this is replacing one thing. We have very good technologies. This I was mentioning about this Trisul technology, and then mechanization at Parbhani, because we developed this complete mechanization, as I said, seed to seed. There is another technology, Agri-PB. It is coming up, agriculture and energy, solar energy generation together. We have a 5-acre, 1.4 megawatt solar energy generation. So doing agriculture and solar energy together. If a team visit us here in we have one at IRI also, another at Parbhani is a big system. If we visit, this is another, this will address even climate challenges also. What we are saying to this group also, I want to say, very important thing is technology for risk management. Farmers are facing everything I have put up in my field, one rain, all devastated. What should I do? So this is, you have to come to risk management. Many technologies are there which can be work for risk management. Drone we were talking. I was responsible for all 4 or 5 committees which Government of India, I was chair for all the committees to develop SOP. Those SOPs are at ICR and Government of India, Ministry of Agriculture website. Please go through. Drone is important, but it should be assimilated, experimented, and then implemented. It's not like throw. Somebody was saying, Suklaji was saying, so you are taking subsidy, taking machine, putting them. So this has happened in some cases in India also. You give subsidy, they will bring it. Then we have to see integration also. Some people are saying tractor ka subsidy inko de do, or machinery ki subsidy inko de do. What is this nonsense? So this integration is very, very necessary. That is another thing. And I say, and then what is important, the message is, even in Nepal, we should think of taking new technologies with the help of entrepreneurs. It's not, universities are not ready. That is Sayed, no. There is no knowledge system, full knowledge system. So I have done 3 things. That is Custom Hire Center, Drone School, and RPTO, all with the industry. So my place is there, my knowledge is there, industry's expertise there, fast system works. Fast, otherwise it doesn't take off. So this is another important thing which we have to see. And I said this robotics, etc., is another very important area which we have to see. CSR funding is required. Government is not going to support. 22 crore and 22.5 crore rupees CSR funding I have invited from my university. Why? But please take help of industry, then only, and they will come with, they have been established Agriculture Mechanization Center, Jhaji, and that is in the heart of this one. They spent 5-6 crore rupees, testing, etc. They are getting benefit, farmers are coming, they are seeing their machine, and so if you give, even some person from outside also can come, and free of cost if you develop, and your technology will be, knowledge and your dissemination automatically will happen. So that kind of ecosystem we have to create, because no longer government is going to support everything. No government is in position, including any government, to take, let me tell you. So this is that type of group. And climate resilience strategies, this is what we are saying, that from chemical agriculture to less chemical agriculture to organic agriculture and to natural agriculture, natural farming we are calling. So that is what we have to say. We have 1 unit which produced during just in month of July 2025, 2 crore 10 lakh rupees from 1 unit. That is like मंदिर वगैरह में जैसे लाइन लगी रहती है, वैसे लोग यहाँ देखेंगे आप, ये सारी लाइन लगी है to purchase that. So university should, they can work in revenue generation mode. It's not only you are academic person. You have to generate revenue. Whatever you have to do, but you have to generate revenue. So this is all agromet advisory that becomes very important in climate resilient agriculture. And then natural farming is one thing. I'm saying natural farming as a risk management agriculture also. I will put less because my agriculture is at risk. So how to reduce input cost? So for that, organic agriculture and natural farming is very, very important. Animal husbandry is, again, you are talking. NICRA, we have been talking, we have been working a lot for and artificial intelligence in agriculture. Maharashtra has taken lead in the country. Very, very, new technologies are coming. And so I was discussing about, with you for cotton, we have 500-acre clean cotton project at our university with industry. So industrial collaboration is very, very necessary. That is what I want to say here, that it was very well said. Coming together is beginning, keeping together is progress, working together is success. Collaboration should be there, MOUs should be signed even during this one. And let us see how a nation can help the other nation, a farmer for one nation can help farmer for other nation. And you have also to institutionalize what I say, farmer to farmer extension.
this is request to you that farmer to farmer extension should be institutionalized. So far just be कहा लोग उसने उसको कुछ बता दिया, लेकिन उसकी संस्थागत जो है डेवलप कि फार्मर को ज़्यादा सुनता है. Thank you very much. So nice of you.
Thank you, Dr. Indra Mani. Now we have come to the close of our first session, and at the end we will be giving token of love to our session chair as well as speakers and rapporteurs. So everyone who presented and rapporteurs, please come up on stage. For this, I would like to invite Dr. Menila Kharil from ID Nepal and Dr. Jit Chand, President of NSAE, to give away the token of love. Please, all the presenters of this session, rapporteurs, please come up on the stage. And I would also like to announce that the certificate of participation for this conference for both the speakers and participants will be provided in your email digitally. After lunch, we also are doing an honoring ceremony of our veteran agriculture engineers. So just a notice. Everybody will get a digital certificate. So first off, we will be providing token of love to our Professor Dr. Indra Mani. Then we have Dr. Shrestha, the lead speaker of the session. Then Professor Chayan Saha from Bangladesh. Then Nath, senior scientist at NARC. Engineer Samir Shakya from IOE. Samir Dai. Subash Adhikari, Secretary, NSAE. Sukla sir and Deepak Dai. Professor Ashutosh Sukla and Engineer Deepak Bardwaj. Please do not go back. We also have to take a session photo of the presenters. Now we break for lunch. We have 45 minutes, and please come back promptly. We'll be starting with honoring our veterans.